Hello, everybody. Thanks for joining us for our industry talk today. Our talk is entitled Visualizing Lighting for Cultural, Arts and Heritage Projects. And without further ado, let's get started. I'll just introduce myself. So my name's Karen Bamra. I'm the Immersive Experience Lead at Hawley. I've generally worked in various different aspects of 3D and visualization for the past 17 years or so. And yeah, now I'm currently the Immersive Experience Lead at Hawley, which is an engineering consultancy. My colleague.
So I'm Chris. Nice to meet everyone. I'm also very similar to Karen in the fact I've been involved in the 3D world now for the past 10, 12 years, but I've kind of been obsessed with the 3D world ever since I was a kid playing computer games. It led me into this 3D world that I just could never escape. I'm sure a lot of people like you who are viewing are in the same boat as me. But I started working at Hawley 7 years ago, and I'm now the immersive experience consultant underneath Karen.
Yeah. So just to give you a little bit of introduction to what we're going to be talking about today. So we're going to give you a little bit of a background on our story, our journey of how we came into this sort of niche area of architectural lighting visualization. We'll demonstrate the importance of understanding how photometric lighting setups in 3D models should be used to accurately visualize the results for really sensitive project spaces. Then we'll have two case studies of previous projects we've worked on. One will be the cupola room at King State Apartments in Kensington Palace. So this is one area of a series of rooms which are known as the King State Apartments there. And what you will see in this case study is how some really unique bespoke lighting proposals were mocked up and detailed in a combination between what was actually in the real space, but then also within the 3D environment that we created in 3D Studio Max. So everything that you'll see here today in this presentation will all be 3D Studio, well, predominantly made in 3D Studio Max, as well as one or two other softwares, but that's our sort of base tool for doing all the sort of visualization work that we do.
And then obviously with the second case study, we will go into the dining hall at Oriole College and Oxford University. This is more of a restoration project, which includes new lighting scheme as well as new decor. But it's kind of how we accurately portrayed these materials using 3ds Max, with in particular challenges, especially with the lockdown at the moment, but we'll go into that a bit later.
Yeah. Okay. So just to sort of set the scene, I sort of got into what I do now here is 3D visualization at about 2002. I just sort of been coming to the end of a degree I was doing in interior design. That's when I first got introduced to 3D Studio Max. So I just want to paint the sort of digital landscape, so you get a feel of an understanding of sort of where we were digitally or at that time. So it was 2002, and this was the best-selling phone that was available. So no smartphones available, no tablets, but pocket PCs was a thing at the time. So closest thing, I guess, you could say there was to a smartphone at the time, but probably only the equivalent power of a calculator or something compared to what today's smartphones can do. That's the kind of machine that I was using typically at home, and we were and at the university, and that's where I first got introduced to using 3D Studio Max, which was version 4 at the time, and it wasn't even an Autodesk product. It was owned by somebody called Discrete, and that's sort of what it looked like. Not much has changed in the look. Probably looks a bit fancier and nicer, sort of dark schemes now with the new versions. So it was around about this time, as I finished uni, I got a position here at Hawley and started training as an architectural lighting designer. Now, the image that you're looking at there is the way we would do lighting visualizations at that time. This is sort of typical thing you'd see, because lighting has always been a really difficult thing to be able to convey for a lighting designer, to get across their design and what they can see or visualize in their head, because they understand what the lighting, how that lighting will work when it hits surfaces and when it hits architectural projects and features. Trying to convey that and express that to the client has always been difficult, and traditionally this would have been one of the ways that was being used at the specialist lighting group at Hawley. So this is basically a photocopy that's been desaturated, and then using pastels and chalk, some light pattern has been drawn onto the building to try and show what the facade could look like if it was uplit. After I joined, we started to explore playing with some lighting tools, lighting design tools that were available at the time. This is a kind of image that we typically start to produce. And really, these were just intended for doing calculations. So you could check lighting levels or plot lighting levels across interiors or exteriors. And the images that they generated, you can see there, it's okay. It's for its time, but it wasn't really anything to sort of, anything spectacular or anything super realistic looking. And it wasn't even ray tracing at that time. It was something called radiosity calcs that we used to get to plot light levels. We started to push the software a little bit. So it was never really intended for visualization, but we started to create simple facade models, or more complex facade models than the software really allowed, because all it would let you do is build square blocks and really basic geometry. So you end up with these sort of Minecraft looking sort of buildings that you build the best you can with the limited geometry that you have. But again, it was still radiosity calcs. So it was better, and it was a bit quicker than doing it all by hand with pastels and chalks, but still needed, still lacking a little bit of depth in realism. Then fast forward a couple of years, I discovered ray tracing. Ray tracing became a capability in the software that we were using at the time. And this was a game changer for me. I just couldn't believe I'd not come across ray tracing before. It'd been around for a while, but I'd just never come to use it in any software before. Suddenly it was getting beautiful, accurate looking fall off and light pattern and shadows on surfaces. And yeah, you can see the difference there. It's still pretty primitive geometry, but you'll just getting a little bit more of a more realistic look and fall off of the lighting. Okay, and we continue to push what we could do within the software. So this is a project that was visualized where the entire church was built with pretty much just cubes. And it doesn't look it, but and then we would do a little bit of post work, so you can see we've added a sky there as well. And the thing here to understand is that this all of this is photometric lighting, because it's a lighting package. Everything that was used within it was only based on real world products. So manufacturers made products or designed lighting products, and that photometric data is made available for them. So when the lighting designer chooses which products or tests products that they want to use for lighting their buildings, they're able to do that within the lighting design software. Yep. So everything that you see there is photometric, because that's all that the lighting specialist softwares would allow.
Did you do a lot of post work on these kind of projects, or is this all out of Relux?
So yeah, the sky was added in post-production. At that time, we were really focusing mostly on trying to convey the lighting impression of the design proposal that was being made. So we wanted a little bit of post work just to add that little bit of realism to that scenario, but it's essentially still a model floating in random space. Yeah. So
Interesting.
we got to a point though that we realized, and we were getting asked more and more by clients about adding details into the spaces, so specific details. The architect had decided on finishes and materials for the space, and we thought we should explore what else we can do. And we had the idea of switching to 3D Studio Max. And I think what was really key to that was that because of that training and that understanding in how to produce real lighting images and real lighting models using real lighting software, we were able to translate that across to what we were doing in 3D Studio Max. So 3D Studio Max allows a lot of artistic license for the user, for the designer who's designing their visuals, to be able to tweak as much as they want to. Really, it's infinite how much you can tweak, but to try and accurately represent scenes that were lit and with the correct light representation or light patterns, we had to sort of narrow that down a little bit and sort of take what we learned in visualizing in lighting specific softwares into 3D Max, and sort of almost limiting what you do and do not change and what you can and cannot play with artistically.
It's a set of rules, isn't it, really, Karam?
Yeah, it's a sort of set of rules, and
Yeah.
we'll sort of show you what those rules are that we have for ourselves when we progress in this talk. You'll see them towards the end. But yeah, here's where we got to. You can see we work on lots of different types of projects now. Over the years, we've worked across retail, transport, residential, etc., and the whole range of environments, interiors, exteriors. But we feel that we've honed our sort of skill in producing accurate lighting visualizations using 3D Studio Max for our projects. So we're just going to have a little look at what photometric lighting actually is, for those who don't know. So every lighting manufacturer, when they produce a lighting product, and here's a typical one, this is the kind of thing you might see in a street or on the outside of a building somewhere. When they produce a lighting product, they get that lighting product scanned. So when the light is switched on, they'll scan a full 360 degrees all the way around it. And what this does is it produces a chart of numbers, essentially, and that's called a photometric file. You see that little chart? That's only a small section of the chart. It carries on that list of numbers, but that's measuring how that light falls off, how that light intensity changes, and the shape and distribution of that light product across all of its planes in 360 degrees. That little animation there shows this one sort of got like this sort of shape of almost like a moth and its wings sort of distributing out from the product. And this is some of the information that once it's saved as a photometric file, we can import that into. A lot of 3D softwares will import it in, but here's the little section on 3D Max where we bring it in. So it can be called an IES file, or it can be called an LUMDAT file. But essentially, a photometric file is a 360 degree reading of the output of light from a lighting product. Okay, so once we put that into 3D Studio Max, there's all sorts of different elements we can control of that. We can set up its lumen output, so that's the amount of light power that is output by this light product, and that depends on different types of lamps that are being used. Then the color temperature of that product, so it could be a warm color, it could be a white color, it could be a cool color. And we can also affect the orientation and the angle and positioning of the product as well itself. I put this slide in just to sort of show you an example of how, while all of the setup of photometric files is crucial to the result that you get, also what plays a very important part is having the correct surface reflectance and values, so physically accurate materials within your 3D model. So look, this is that lighting product, external lighting fitting. both images there have that output of that product set to exactly the same setting there, 7,000 lumens each, but you can see that there's a difference there in what you're seeing. And the reason for that is just because there is a difference in the material that's been applied to both of those scenes. So the column is at a 40% reflectance in the one on the left and 10% reflectance the one on the right, whereas the floor itself is 20% on the image on the left and 50% on the right. So even if your lighting is set up correctly and perfectly, if materials aren't set up correctly, then you're going to get a wrong representation of how that space might look when it's completed. So we have guidances that sort of we can use because we know there are known reflectances of materials such as stone, such as wood, such as glass. And it will vary depending on the type of wood you're looking at or the type of surface finish on that wood, whether it's glossy, whether it's satin, whether it's matte, the color of the grain of the wood itself, and so on. And even the age of the wood can affect it. So these are all things that have to be considered. So even though you know that there's a known sort of diffuse level of this particular type of wood, you have to still consider, right, how is it being stained? How old is it? What's it sort of patina? What kind of finish is on the surface of it? When you're making those decisions on how to set it up in your model. So we'll see a little bit more on some examples in the case studies on that a little bit later on. But typically, we come across this kind of thing. So this is actually a project, Radley Hall College at Cambridge. Is it Cambridge?
That's correct. Yeah. So this was actually a Cambridge project. Yeah.
Yeah. So we actually sent this model. The model's great. Model's made up of the space once they did a survey of it, but the attempt was made to light it, and this is what I like to sort of refer to as sort of film set lighting. So somebody's made an attempt here, you can see, to put in fill lights that come in from the outside. So there's daylight coming in, and then sort of generally make sure the space is well lit. So you've got those area lights down the center of the space, and then where you've got these little lamps that are on the benches on either sides. Again, they've used some area lights to sort of represent each one of these lamps. And at first glance, that looks okay, but when we take a rendering from that, you end up with quite an overblown space because there's basically just too much light in there. It's just it's not accurate based on where the actual positions of lighting products in that space would be. But then also a lot of that sort of washed out look is because the diffuse and settings of the materials haven't been taken into consideration there. So on that specific project, once we've gone through this with the lighting designer and placed products accurately where they should be, you can see that suddenly there's a difference. Everything seems to have a purpose as to where it's being placed. You've got light in the center there, which are aimed at specific parts of the walls. You've got lights on the suspended chandelier products and so on. And again, we'll also go through and check all the diffuse levels and the physical setup of the materials, and the result that we get once that's been done with everything checked and correct, you can see it's a very different experience of that space, and the representation of that lighting in there gives you a much more believable or a much more accurate representation of what that space is actually going to look like once it's been completed lighting wise. And just to demonstrate an application that we also use, so based on the different light passes that we can take through Studio Max, we've generated this small little application which we call a light sim. And what this lets you do is really get across the point of using different lighting elements in a space to a client. So there's a little interface that pops up, and the client can play with these different lighting elements, and they can understand what the different treatments are for different parts of that space. um, when a whole bunch of lighting products are all placed in together, it can be difficult to understand what they're all doing. So here, this really sort of explains that we've got spots on the tables, we've got lights on the window recesses, we've got lights on the actual photos that are hanging in the space as well, and they get to understand and see what all of these different elements are doing and how they build up the scheme for the whole space. So again, this is all created in 3D Studio Max, then put together in a small a Windows-based application for the client to be able to use. And this is just to sort of demonstrate how accurate representation can get if all those elements are set up correctly. So this is a visualization that we did of this space, which is Trinity Hall, dining hall. And this is the photograph of the final installation. So where you can never always get everything 100% accurate. You can't control the daylight coming into the space is going to be, for example. You can't, and sometimes there's late decisions on paint finishes changing and so on when the installation was taking place, or a product or a photo or something might change. But generally, you know, the difference there, if I go back to that picture, is pretty accurate, and clients are usually really happy with the seeing this kind of visualization to help them make their decisions on what they want for that space lighting wise. So stakeholders love seeing this, especially for these types of projects, arts and heritage, where stakeholders haven't really got any experience of working with. They're not trained in working with drawings, and they're not lighting design trained or anything. So having a tool which is really clearly explains and presents things for them visually, and that allows them to make those decisions based on what they can see and what they can interact with those different lighting elements. It goes a long way to helping the clients and stakeholders understand what they're going to be getting for their space. Okay, so we're going to move on to the first case study we want to share with you, and this is for one area within Kensington Palace called the King's State Apartments. It's actually made up of 3 or 4 different rooms, but the room we're going to show you today is one called the Cupola Room. So Kensington Palace itself was actually built in 1605, or well, at least there or thereabouts when it was completed. And the King's State Apartments were an area where the king of the time would actually wine and dine guests. So they would come, and you can imagine there's people in this space of the period, and it's sort of an entertainment sort of room, I guess you would call it. And there's a room next door to it where they would have some games and things for them to play and talk and mingle as well. But the idea for this room was that they wanted to restore the lighting best they could to how it was when the space was originally built. So if you look at some of these pictures, what you'll see, for example, on the top right there, when this space would have originally been built, obviously there was no electricity at the time. So there was no artificial lighting at all. The only lighting was either provided by candlelight, or if you were rich enough to be able to afford it, you could have fuel oil lamps, or you could have gas lamps. But over the years, as artificial lighting did become available, it's been added to this space, but it's been added in a sort of a bit of a clumsy way, actually. If you look at the top of those door entrances, you can see all these 2 or 3 different sort of types of light fittings, or scattered along the top of that cornice there, and they're aimed and pointing at different elements. And some of them, maybe they're a bit too bright than they should be, and they're different color temperatures and things like that. So that was part of the reason for restoring this space. They wanted to get rid of those, make them invisible, no lighting products visible at all, but then also try and recreate that feeling of how the space would have looked when it was originally built, and it was only lit by candlelight alone, candlelight on those chandeliers in the space. There's a lot of heavy detail in in the space. Some of the detail actually is just painted onto the surfaces of the walls there, painted in such a way that it looks 3D. It looks like it's really there. But then there are a lot of statues, a lot of cornicing, edging, and then you've got those wonderful chandeliers that hang in that space as well. So all of this was going to be recreated in 3D, because when our lighting designers start to design their lighting scheme for the space, our job would then be to visualize it and present it to the stakeholders so that they could make their final decisions on what these proposals are and for lighting that space, and sign off with the chosen design. So one of the first things that was done was the space, because of how complicated it was, because no drawings or models existed of it, funny enough, the space was scanned. So there were this scan here showing a few of the different areas that were captured. The cupola room is that big square one at the back there in the middle, and you can see a black and white scan there of the interior of that room. Once we had those scans, the next part of the process was to start building up the space. So we did this in a combination of ways when we start building this geometry. So most of this was done by Chris, but we first technique we used was manually build point on top of the point cloud. So it's just like tracing or joining the dots, elements, simple structures and simple elements or architectural elements in that space, just built up using the point cloud as a guide for positioning and heights of extruded objects and geometry until you fill it all in slowly.
Yeah, it's kind of like it's as you say, it's like tracing, but it doesn't really speed up the modeling process, but it kind of ensures accuracy, I guess. Like you can make sure scales and everything are as they should be. They should be the correct scales. So it's really useful for detail, like heavy detail on ceilings as well, because obviously you can't get up close to those when you're there in person, but the 3D scan will get that detail for you.
That's correct. So as well as that, some of the really heavily detailed items in that space, like that statue, for example, they were a little harder to model in using the point cloud. So the way those were done was using mesh processing softwares. I think we used Mesh Labs for this at the time.
Yeah, we did. Yeah, I mean, it's quite a, as you can see, it's quite a dirty method of creating geometry, but it was good enough for the statues there. I mean, especially once we applied textures to them, you can barely notice.
You see the statue there on the left, and then you see the point cloud. Obviously, the point cloud didn't capture so much of what was going on behind the statue, or there's bits of like feet and things missing. When we ran it through some processing software, we were able to get that clay version there. At first glance, it looks great. If you really analyze it, then you notice things like, oh, there's a bit of foot missing, or there's not as much detail maybe in some of the clothing, etc. But once Chris does magic on it and cleans it up a little bit, and once we have placed the textures onto it as well, then it becomes really quite hard to perceive that there is anything different to the original. And you can see here, this is some of the detail that was on top of that central clock feature in the middle of the space.
Yeah, so it's quite as I say, quite a dirty model that you get out of the processing software, but just some simple cleanup. It doesn't have to be perfect or accurate. Well, obviously accurate is important here, but I mean, like the actual volume, as long as we fill the volume that's there, that's the most important bit. And obviously, depending on where the camera is positioned in the space as well, is kind of how much detail we need to go into. So yeah, and then we can use textures to add in the extra detail where necessary.
Okay, so here you can see the architectural sort of model that we generated then of that space. So we've got all of the base room in, we've got the details in for those elements, the ornaments in the background, the detailing around doorways, and the feature clock in the middle, and we've got the chandeliers in as well. So from here, the next stage was to put in the materials and build up using a lot of photographic reference was used for this space.
We were quite lucky
Um,
when we went to the site, weren't we, Karen? We
yeah,
actually got a chance to take a lot of photographs for our reference as well, and we were able to
yeah,
take them in a way that the exposure for the images was just right for us to use them as textures as well, trying to
correct.
remove as much of the existing shadows as possible so we could actually use them as well.
Yeah, and then it was just the process of unwrapping the geometry so we could place the textures on accordingly. And you'd be surprised how much you can actually get away with where things aren't absolutely perfectly lined up. But as long as you've from a certain distance, as long as you've got them, within 95, 98% accuracy, they just look like the real thing once you view them from standing back in the space. So there's just a few there that we showed you, but there's literally hundreds and hundreds of images taken and hundreds of elements chopped up in Photoshop and placed onto that model. So that's the scene. That looks. You couldn't actually go in there and take one image of the entire ceiling. So that's actually I can't remember how many.
It was like
images.
5 or 6 images stitched together, I think, in the end.
That's right.
To try and get a flattened version of it, which we could use.
Yeah, and to try and get as high a resolution map as possible.
Yeah.
And then that's just applied to the inside of that ceiling space. Then you can see also there's one of the main wall in the space there where the fireplace is, and the texture that was created for the base texture that was created for that, with all of the painted details on those walls and columns. And meanwhile, while we're getting the model and ready and textured, our specialist lighting team was also working on the lighting design for this space. So if you remember, I mentioned before that what they wanted to do, the aim of this client was to try and restore the ambience or the feel or the mood in that space back with the lighting to how it would have been when it was originally lit just by candles. So we headed down to Kensington Palace for this candle trial, they called it. And Chris and I have worked on quite a lot of different types of heritage projects like this, and we know the level of detail that stakeholders and clients can go into when they're making decisions on things for these spaces. They're very sensitive spaces. They're hundreds of years old, and they belong to important people, or they're used for important things. So a lot of time, effort, and a lot of input is required from a lot of stakeholders to make decisions. But this just took it to another level, right? For us,
big deal for them, wasn't it? I mean,
it's a really big deal.
Like it's the first time they lit a candle in the space for hundreds of years. So
exactly. Obviously, though the space was originally lit just by candlelight, and the candles were specifically just on these chandeliers, they can't do that for obvious reasons. That can't be done today. You couldn't have candles lighting up this space and visitors coming in and out. The risks and the hazard that would cause it's not going to happen. So what the lighting designers had to do was try and mimic the appearance of candlelight using an LED lamp source, so it doesn't heat up, but an LED lamp source that replicates as close as possible what the candlelight is doing. So the curators at the palace arranged for a bunch of candles to be made by hand, because they wanted to use candles that were produced in the same technique that would have been used in the 1600s when the palace was first built. So these are handmade candles, and what that does actually is, because it doesn't have the sort of chemicals and things they add to candles when they make them today, these candles will burn a lot quicker. And you can see they had the special fire blankets on the bottom there. They had fire people, firemen there as well, in case there's any problems or anything went wrong. But they essentially lit some candles on one of these chandeliers, and some measurements and pictures were taken of the sort of light level that was being achieved from that one. The lighting designers we work with, what they did then was they had a bunch of different lighting lamps, which try to replicate. You're never going to be able to 100% replicate what a candle does, but these fittings are designed specifically to try and replicate what a candlelight does. You know, the same sort of warmth of a candlelight, the same sort of distribution as candlelight. And they tested different ones there to see what they felt worked best, not just in the light that spread from it and the color temperature of the light that spread from it, but also what looks most like an actual flame there. As well as that, they mock up and they test. Well, we can't mock up all the light fitting in the whole space, but they'll take an individual 1 or 2 lights and take them up to, so this is the ceiling there, we'll take them up and place them and play with them a little bit. So you can see here what they're doing is they're playing with the position and the tilt and the angle of that lighting, that linear light fitting. So what you can see, I don't know if you can just make it out, but on the left there, it doesn't quite reach up high up towards the center of that space on the ceiling. But then on the right there, you can see it's got, because they've tilted it in particular angle, now you can suddenly graze up that ceiling a little bit more. So they'll do that on site, and this is a two-way process. So once they've made some decisions, it's not the final decision, but they made some decisions as to which light product they want to use, where it's going to be positioned, what sort of orientation it's going to be angled at. They're able to feed that back to us, so they'll provide us with drawing layouts showing us exactly, so there's a plan there showing where all those fittings on the chandelier go, where the fittings around the ceiling cornice go. So as well as all the information about where those light products sit on the plan, we also get all the details of the specification, full specification of those products. So the output, lumen outputs of the products, the color temperatures, etc. So we'll populate that into our model. You can see there's that linear fitting and where it's positioned exactly on the underneath the ceiling on the cornice at the top. And this is a really good example of working on something that's bespoke. So the lighting designers worked with the company that was restoring the chandeliers, or there was some repair work to be done on some of the chandeliers, I believe. But they wanted to also integrate this fitting of spots. So there's a ring of spots. It looks like a spider there. You can see it on the left. And it's colored the same material as the chandelier itself, but then also it's hidden in between those arms in such a way as to hide it best we could. So each one of those little cylinders that you see holds a high intensity LED spotlight. And the idea for this was because they wanted to make sure that there was no spotlights to light all of those statues and busts and pieces of art that were around the space. They wanted to make sure there was nothing visible or mounted onto any of the surfaces of the architecture. So by hiding them on the chandeliers, you could aim them at different elements. So here's a drawing that the lighting designer gave us saying, okay, we've got 4 chandeliers and we've got these rings on each chandelier. And this is sort of where we want to aim products to. So Chris and I had a great time trying to sort of figure out which arrow points where and where it comes from. But we did a rough setup to sort of point best we could these spots from the chandeliers to those particular different elements within the space. Here's a video. I think we've got a video here showing how that works. What was really good about doing this in 3D Studio Max was that once we parented up the light fitting to the spot, you can see it follows wherever we aim it, but we could position it and aim it towards statue, for example. And when we do a test render, then we could straight away see whether there was clash happening, i.e. is there a arm of the chandelier that's intersecting this light beam, and you can see there's a dark shadow on the side of that statue there, and that's being caused by one of the light one of the arms of the chandelier blocking the light beam from that spotlight. So yeah, you can see the image there as well that shows it. So this way we were able to then choose a different position or a different spotlight from one of the other ones. Maybe we choose one from a chandelier across, or just one from the next arm down maybe. So from that we were able to work through all of those spots on each chandelier and figure out exactly which position we needed to place a spot and what aim we needed to set it to, what angles of aim we need to set it to light just the required elements of statues and artwork in the space without causing shadowing from the arms of the chandelier itself. And then we did some test renders as well, just to go over that with the lighting design. And you can see there that, so this is all of the spots only. The rest of the lighting in that space is off, but just the spots are on, the ones that are aiming at different elements in the space. And yeah, you can see that pretty clear. There's no shadowing being caused by any of the chandelier arms. So we managed to sort of just find the right gaps between them to aim at what we want to aim at without spoiling the view. And that was quite a long iterative process that we went through with the lighting designer.
Was, and I remember actually because I think you can never quite 100% eliminate the clipping of some of those chandelier candles, but you can get it to a point where it's quite tidy. Yeah,
it's tidy as you can get it. Yeah. So once they're happy with that, we turn on all the rest of the lights, and that's a view of the lighting scheme for that space. So this is the view from the opposite direction. So you're standing in front of the fireplace looking towards the windows here. And this is showing it with the levels lowered down on the ceiling. So it's a little bit more into a little bit more of a moody space, probably closer to how it might have looked with just the candlelight on. But we had to present, as well as these images then, we also produced the interactive light sim for the client on this one. You can see that on the video next. Here we go. So what this is showing is, what I mentioned before, that it breaks down all those different lighting elements for them so they can play with it themselves. What these are really good for is allowing them to sort of decide as to what level of light they want on as well. So maybe they only want the spotlights all at about 50%, but they want the chandelier lights to be on full, but they want the ceiling reduced to something 40-30%, whatever. When we put this tool in their hands, not only are they able to see those decisions or make those decisions instantly, but see what the effect on the space is going to be as well. Stakeholders love this. They love having this presented to them in such a way.
Yeah, it's much better than just having a still image, having the interactivity to be able to just play with the scene. As it would be. It's a really good tool for them
it's just
to have, right?
the level of understanding that they get from the space then and how it's going to change different lighting scenes. Just can't be matched really. So okay, that wraps up what we wanted to share with you on this particular case study. We can move on to the next one.
It's Oriole College, which is actually a part of Oxford University. It's more of we're actually going to concentrate on the dining hall in this one. So this is a very old building, just like Kensington. It was actually originally constructed in the 1620s, so it's a super old building as well. But like a lot of these old buildings, they go under a lot of restoration projects over the time, and this one's seen several over the years it's been around. With each restoration project, it would have new wooden panels put in, ceilings would change. It actually had a flat ceiling at one point, which was taken out in the early 1800s. And it has new lighting has been put in on occasion as well. As you can see that the image on the right, which was one of the restorations done in the late 1700s, early 1800s. You can see the gas lanterns mounted onto the walls there, and the different types of wooden paneling as well around the room.
When we get these kind of projects, Chris and I always love looking at all of the drawings, original drawings that were done by hand for these kind of space is amazing. And there were some great ones for this one, weren't there, Chris?
Yeah, some fascinating ones. I can never read the handwriting because it's always so neat. Not like my handwriting, unfortunately.
Everybody could write in calligraphy back in the day, couldn't they?
So concepts were drawn up by a couple of architects, actually, of how this space could look if it was reserved or preserved. Looking at the new wooden paneling as it is now, and the frieze and the furniture was all going to be completely renovated. Also, they were going to rehang all the portraits, actually taking down quite a lot of the clutter on the walls and reducing the number of portraits in total in the space, but also bringing them down so that they're more eye level, so people can actually see some of these portrait paintings. As well as this, there's going to be an updated lighting scheme put in, mainly to focus on actually hiding as many of the fittings as possible for minimum visibility, to make it a bit easy to maintain as well, because some of these fittings are so old. It's quite difficult to get the actual parts to fix them if they do break, and also to provide a better quality of light in the space as well. So just for your interest as well, these are some of the designs that the lighting designer came up with conceptually. So you wanted to have a ceiling wash in there, some new picture lights, LED picture lights, LED linear fittings to kind of bring out the timber details on the balcony, and also to bring out some of the stained glass windows too, as well as actually having some proper task lighting, some down lights to actually illuminate the floor. Also, yes, as I mentioned before, task lighting was quite a big thing for them, because at the moment they have lamp fittings on the actual tables, but they're hardwired in, so that they can't actually rearrange the tables in the room at all. So the idea with this is that if they have a battery powered table fitting, they could actually rearrange the tables and actually use the space for other things other than just sit down meals. They could have concerts or exams in there. That's what they really wanted to do. They wanted to repurpose the room.
Yeah.
So actually, when it comes to recreating the dining hall from scratch in 3D, it was quite a challenge for this job in particular, because we actually did this project in the beginning of lockdown with COVID-19, so we can actually go to the site and see it, which for us, and actually doing lighting visualization, it's really handy to actually go and see it with your own eyes. Unfortunately, with this job, we had to just deal with whatever we had in terms of reference photographs, or which were generally taken on mobile phones. And no offense to the people who take them, they're not photographers. They don't really know how to balance exposure and white balance and all that stuff. So we kind of had to use numbers of different sources to try and recreate the space as best we could. Thankfully, we did have a point cloud given to us, which really helped with getting the sense of scale correct and making sure the details, especially on the ceiling level, getting them just right, getting them to the right size and getting them positioned correctly. As you can see in the video here, it was really useful for getting all the windows and the columns in place. It's interesting to see actually where all the old pictures were in the scans as well, as you can see them there just floating around, but obviously they got moved. So it's kind of a weird thing to see. It's worth mentioning actually as well, before we bring the point cloud in, we actually use Autodesk Recap Pro as well to actually adapt and just to clean up some of the point cloud as well to bring in. But then we do use a limit box in Max to then just show or hide just areas that we're interested in at the time when we're modeling these things.
It's great for doing that kind of stuff, and especially when using the limiting box, then you can just isolate and concentrate on just a particular element that you're working on.
Yeah, it's really handy for doing those little detailed areas, especially for the frieze area. But then we moved obviously onto creating the materials, which again was another challenge of not being in the space.
I think it was quite crucial for this one as well, wasn't it, Chris? Because not only did you have to it's always crucial for these kind of projects to recreate the materials as accurately as you can. But here there was quite an emphasis on restoring some of the damaged materials, but then also there were some new materials or choices to be made on paint finishes and colors.
Yeah,
and things.
absolutely.
So,
I mean,
and that was crucial for them.
It was indeed. The challenge was, as I said, it comes down to the photo references we were given. They're all different, varying levels of focus and exposure, it's hard to try and nail down the existing materials first, which I thought was very important to get. If we get the existing materials done first, we could then adapt those to then make them look like the new materials, or look more like, for example, the wood that we had to create here. We actually created the scene and then mimicked the lighting in the photographs that we had received, which is kind of like an overcast daylight, I guess, and then recreated the existing wooden material first. And when we do that, we have to take in consideration how the light's going to react with that material first. So as you explained earlier, the diffuse reflectance that you said, there's all different types of diffuse reflectances for different materials, and for wood in particular as well. And then we also have to take into consideration the surface texture and the bump of that texture and the glossiness. It can't be overdone. It has to be just right.
I think what also contributes, what really has to be considered, and the only way we can really do this is by analyzing as many photographs or actually visiting the spaces as where possible. But what really has to be considered is that a lot of these materials, because they're hundreds of years old, these panels on the wall, they almost there's a variation from one panel to the next panel. So it's not going to be necessarily the same as it would be if it was just built yesterday and varnished.
Yeah, you're right, actually. I mean, like for example, the wood between the roof and the wooden paneling on the sides of the room, it looks the same, but actually it pretty much is the same wood, but they one looks darker than the other. And that's probably down to the age as well, because the roof is very old and the wooden paneling around the room is relatively new in consideration. I mean, it's still 100 years old, but it's probably a lot newer than the actual ceiling itself. So
which is a few hundred years old.
Yeah, exactly. So moving on to the frieze, which is the detailing you can see here. This is quite an interesting part because this was considered to be one of the most crucial elements to get right in the space. So they actually wanted to paint this frieze and actually add a bit of color into the room. Obviously, because of the nature of the ideas they had, they actually decided they were going to 3D scan this element, and they actually made mock-ups, 3D printed some mock-ups for an appointed artist to actually come in and do some different color schemes, paint some color schemes onto the actual prints. This was the final concept that they came up with. So we had to recreate this in Max, but we decided to kind of create it in a way that was kind of non-destructive. If they did decide they wanted to change this color scheme a bit later on, then we can do that really easily. So
there was quite a lot of tweaking of the exact finish, exact color, the RAL colors for those paint finishes anyway during that time. So the artist gave those concepts of what it should be, but then once they saw them in situation with daylight falling on them up against the wood finish, with artificial light, then I think there was some tweaking that went back and forth where they changed for a light shade maybe, or a dark shade.
There was quite a lot of backwards and forwards actually between the architects and ourselves until we got the color right. So that's why we kind of created the material in this way, using masks to mask off the certain areas of the frieze which were going to have different color features on them, and using a blend material in the slate editor in Max, it's very quick. It was very easy and quick for us to change if needed. So at this stage, we were kind of ready to start placing in the photometric lighting into our scene. So very similar to how Kensington worked, we had a lighting design specification supplied to us, and we were able to source the correct photometric webs, or IES files, as Karen mentioned earlier, to accurately show the exact fitting in the space. We placed each set of lights around the room, ensuring that all the outputs were correct and the color temperatures were as the lighting designer intended, and making sure they were all aiming in the right place. But we did this very interactively with our lighting designers. So we like to share our screens with them quite a lot. We open up the interactive rendering, and we like to make changes or try new things there and then, or change the positioning or targeting of lights to see how the effect will come out. It's a really useful feature to have for them, and it's good fun actually to play about with this with them as well.
Yeah, when lighting designers work in this way with us, then they absolutely just love it, because traditionally they might be using, well, firstly they can't render but they can't produce models or geometry to this level with the lighting calculation software that they use. But then also they cannot get a demonstration or example of what that change, these small changes, or just by moving the position of a light or increasing its color temperature or increasing its output or halving, whatever they want to do, they can't get that instant feedback with the kind of tools that they're used to using for lighting calculation. So they absolutely love it when we can show them their space in this way and let them design on the fly and make those decisions and choices or changes on the fly.
Yeah, it's like the holy grail for them.
Yeah.
So this is actually a draft render that we sent to them. We had tweaked the wood material slightly to kind of make it a bit more restored, but they did feel it was still a bit more too dark. So we had to go back and make some more changes to ensure that the wood elements were kind of as they should be. So we had to make it a lot lighter, and also we had to change some of the picture sizes and locations as well.
Because they intentionally wanted to lighten the wood on certain elements in this space, didn't they, from what it originally was?
They did, yeah. So
right?
Yeah, they were. So they were probably going to restore a lot of the stuff, including the furniture as well. So it's all going to get sanded back and revarnished. So it was going to look a lot lighter than what it did originally. So once we got all our feedback and made all the alterations, we then went on to rendering the final layers, which we actually do in separate layers as well. So we render all the lighting as separate individual images, so that we can build an interactive for them at the end. Once we combine them all together, obviously you kind of get a final image like this. This was the image once we had made all the material tweaks and alterations. This is another view looking from the opposite side, looking down the space. And then we also have a close-up as well of the frieze, so they can see a bit more of a detailed view of that. So we also made a light sim for this as well. For the main purpose is so they could reuse the room in different ways. They didn't just want to have to use this room as just a banqueting suite. They wanted to repurpose it for weddings, for concerts, for all different types of things. And this was going to allow them to set different scenes for those different types of purposes that they wanted to use them for.
Yeah. You could explore and experiment with, how do we want this to look when we're having an intimate evening meal, for example, or maybe there's a day event going on. So, we want a completely different feel or scenario for that space.
Yeah, absolutely.
I loved using this again for that kind of purpose.
Did. Yeah, so Hampton Court Palace, this is actually the Cumberland Suite, which is 3 separate rooms, and they were actually repurposing them from basically bedrooms into an art gallery. So they're adding a lot of portraits and pictures from the Royal Collection into the space, as well as new decor and a new lighting scheme. So we generated these 360s so that they could actually stand in the space and see how the new scheme would look. It's a really useful tool for them, just to experience the space rather than just looking at a still image.
I think with this one in particular, there were about 25 or so stakeholders that had to sit and understand what these new proposals were going to be, and presenting them in this way for them was just fantastic. Not only were they getting an accurate representation of what the spaces would look like with the new finishes and the new lighting that was going into that space, but they were instantly able to make decisions or make suggestions on changes. And it was all fully immersive, so you could access that web link on any web-enabled device. Yeah, it's really good. So following on from the 360 links, what we're also doing now is exploring how we can do a fully virtual environment, but we wanted to do something where you could still interact with the lighting. So this is a space that we explored, creating a virtual version of the light sim, essentially. So you can bring up your interface and control all those different elements and really feel like you're in the space and you're exploring how it's going to change and depending on what light treatments are switched on or off or dimmed.
Yeah, you can change the material in the space as well, can't you, to make it darker? I think that's just about to happen now. So you can really see how difference in material finishes can actually make a huge difference to the lighting impression in a space.
Yes, that's right. And again, all of this that we've just shown was all created in the same sort of in the same workflow that we presented with 3ds Max there before on those 2 case studies. Right. So okay, we're just going to summarize up with what we sort of feel are like our key sort of 4 principles for doing this type of visualization of lighting in heritage spaces. So yeah, these are just sort of our I suppose they're our golden rules.
Yeah, our mantra.
That's right. We'll try and follow these whenever we're working on these types of projects. So correct 3D geometry, using reality capture, using photo references wherever possible, photogrammetry.
I think having accurate 3D geometry of a space like this is super important, especially when you're conveying lighting as well. You want it to be, you want everything to be to the right scale and physically accurate, I guess.
And the thing to remember is that a lot of these kind of spaces, old buildings that have been built hundreds of years ago in some cases, and nothing is completely square in them, and nothing is simple. There's not really any flat walls and ceilings. It's all really heavily decorative and heavily detailed and ornate. So you need some way, preferably, to help you capture all that detail. You can't build it all from scratch
unless you have a lot of time, obviously.
Unless you have a lot of and physically accurate materials as well. So again, because there's a lot of old materials and surfaces and finishes in these spaces, and the decisions that have to be made on preserving them or restoring them, vital that we're showing and representing those as physically accurate as we possibly can.
As we mentioned before, making sure that diffuse reflectances are all correct and all the reflections, glossiness, and bump maps are all set up in the right way, so it's actually representing the material as it should do. So when the lighting is bouncing off those materials, it's acting as it should do in real life.
One of the things that we do quite a lot of when we have access to these spaces is then try and set up some balanced lighting conditions and take some really high-res photography there on site of certain elements, depending on what's going to be visualized. That always helps, being able to use your own high-res photography. And then the photometric lighting setup. So understanding that real-world lighting setup and what the units all mean, what the color temperatures all mean, how positioning and orientation of fittings will affect that space, and really, on a project of this nature, you've got to be working with a lighting designer, which we always do. We're always working. Most of our projects are with our in-house specialist lighting design team. But there's got to be that. To get the space right and to get the visualization and representation right, you've got to have that working between them. So it's very much an iterative process of going back and forth.
Yeah, it's a valuable resource to have, isn't it? Having a lighting designer, having a look at your visualization as well, because they know the lighting effect that they want and how it should look. So they can help you with the tweaks required to get it to that stage.
Too often it can be the case where maybe someone has provided a specification for where light fittings go and what the product is, but it's not. That doesn't mean it's as simple as just putting in those files, loading them into 3 Max or whatever software it is you have to be using, and then running it, and whatever the result you get is right. That it doesn't work like that.
No, that's true.
No. Okay, and final output. If the lighting that's represented in a space isn't correct, then how can they make a decision on what that new wall covering color should be? If it's too, if you haven't set up the correct color temperature, because everything, the daylight coming in, the color temperature during the morning, the color temperature during the evening, etc., and spill light from other fittings, all these things all contribute to what that final color on the wall or the floor is going to look like. Absolutely. Of that material.
Yeah, and the same with the material as well. Like, if the material isn't correct or set up correctly, if the diffuse is too high and it's coming out too bright, obviously in reality that's not going to happen. And obviously if you over tweak this as well in Photoshop afterwards, it's going to be even more blown out. So you kind of have to try and not fill with the images too much afterwards. With in terms of color and exposure, and playing around with the shadows, you kind of want to try and keep that to a minimum.
I suppose it can be tempting for visualizers
Yeah.
to look at the final image and go, "Oh, I need to give a little bit more of a punch. There's something a bit lacking here."
Yeah, I think you can within reason, as long as you're not kind of.
It's got to be within the tolerances, and you've got to understand what the tolerances are of what you can play with. Because what we don't want to do is we don't want to make it seem like it's a lot brighter than it's actually going to be with that lighting installed, or the color of a certain finish in that space is going to appear differently just because we've punched it up. Okay, great. So I think that's us done for our talk, and yeah, thank you everybody for listening, and hope you enjoyed it, and hope you learned something about our little world that we live in and work in. Yeah, thank you very much, everybody.
Thank you very much.